Close your eyes for a second. You're floating in space. No gravity, no sound. Just you and an infinite ocean of stars stretching in every direction. And then, you notice it. A darkness ahead. Not like nighttime darkness. Deeper. A place where light itself disappears. Where the laws of physics start to break. You try to pull back, but it's too late. You've just crossed the point of no return. Before we send you to your doom, let's get one thing straight. What even is a black hole? Think of space like a stretched rubber sheet. Everything with mass sits on that sheet and creates a dip. The bigger the object, the deeper the dip. Now imagine something so massive, so compressed, that it punches a hole clean through the sheet entirely. That's a black hole. They form when a massive star, we're talking something 20 to 100 times bigger than our sun, runs out of fuel and collapses in on itself. The collapse triggers a supernova explosion, and what's left behind is a gravitational monster. Here's something most people don't know. Black holes don't actually suck. They don't vacuum up everything around them. If you replaced our sun with a black hole of the same mass, Earth would keep orbiting just fine. The danger is only if you get too close. And close is exactly where we're headed. The journey begins. So here you are, drifting closer. The first thing you'd notice is the light. It's wrong. Stars behind the black hole appear to wrap around it, bending into a ring of white fire. This is called gravitational lensing. Gravity is so intense here that it literally curves the path of light. You'd see the entire universe folded around a single dark circle. Stunning. Terrifying. Both at once. Now comes the part that sounds like science fiction but is completely real. Time starts to slow down for you. The closer you get to the black hole, the more gravity warps space-time. And time is space-time. Your clock, your heartbeat, your thoughts, the aging of your cells, all of it begins to tick slower relative to someone watching you from far away. You wouldn't feel it. But to your friend, watching from a safe distance, you'd appear to be moving in slow motion, almost frozen. And then, spaghettification. Yes, that's the actual scientific term. The gravitational pull at your feet is so much stronger than at your head that your body gets stretched out like cosmic pasta, vertically elongated, pulled apart atom by atom. For a stellar mass black hole, the smaller kind, this would happen before you even crossed the event horizon. You'd be shredded before you got close. But for a supermassive black hole, the kind at the center of galaxies, like the one at the heart of the Milky Way, Sagittarius, a star, the tidal forces are gentler near the event horizon. You might actually cross it intact. Crossing the event horizon, the point of no return. It's not a wall. It's not a surface you can touch. It's just an invisible boundary in space where escape becomes mathematically impossible. Not difficult. Not dangerous. Impossible. Not even light, the fastest thing in the universe, can escape from inside this line. Here's the wild part. If you were falling into a supermassive black hole, you might not even notice the moment you cross it. No explosion, no flash, no warning alarm, you'd just be inside. But here's where it gets really strange. Remember your friend watching from a distance? To them, you never actually cross the event horizon. They see you slow down, redden, as light gets stretched to lower frequencies, called gravitational redshift, and gradually fade into the darkness. You appear to freeze at the boundary for eternity. From your perspective, you cross it in finite time. From theirs, you never do. Two completely different realities. Both correct. Both valid. Christopher Nolan got this right in Interstellar. When Cooper falls into Gargantua, he crosses the event horizon, while those watching from outside see him frozen in time. Real physics. Genuinely. Okay, you've crossed. You're inside. No signal you send can ever reach the outside world. No light, no radio wave, no information of any kind. You are completely cut off from the rest of the universe. What happens next? Honestly, we don't fully know. But science has some fascinating theories. At the very center lies the singularity, a point of infinite density, where our known laws of physics simply break down. Einstein's equations output the word infinity, which in science is basically a polite way of saying, we have no idea what's happening here. Some physicists think the singularity doesn't really exist, that it's a gap in our understanding, and a better theory of quantum gravity would replace it with something we can actually describe. Then there's Hawking radiation. Stephen Hawking theorized that black holes aren't truly eternal. Over incredibly vast timescales, they slowly leak energy in the form of quantum radiation and gradually evaporate. A stellar black hole might take 10 to the power of 67 years to fully disappear. The universe is only 14 billion years old. So, no rush. But here's the question that keeps physicists up at night. When the black hole evaporates, where does all the information about the things it swallowed go? That's the black hole information paradox, and it's still unsolved. And then there are wormholes. Some equations suggest that the interior of a black hole could connect to another point in space, or even another universe entirely. A tunnel through the fabric of space-time. We have zero observational evidence for this. But mathematically, it doesn't break any rules. You could, in theory, fall in and come out somewhere else entirely. Black holes are the universe's most extreme objects. They warp time. They devour light. They may hold secrets about the very nature of reality that we haven't even begun to understand. And here's what I find most extraordinary. We can't go there. We may never go there. But we can think our way to the edge of the event horizon and peer in, armed with nothing but physics, curiosity, and the strange courage of the human mind. Here's a question for the comments below. If you could fall into a black hole, knowing it was one way, would you do it? Just to know what's on the other side? I genuinely want to know. Drop your answer down there. If this video blew your mind even a little, hit that subscribe button. We go deep on space, science, and the biggest questions in the universe every week. And if you want to choose the next topic, leave a suggestion in the comments. Your idea might become the next video. See you out there.